Hi everyone! This video looks at a strong base titrated with a strong acid and will focus on the pH calculation at the equivalence point. If the titrant volume in the problem is more than 0 milliliters, then we know that we have to set up a millimole table. The E row of this millimole table tells us where we are on the titration curve and guides us as to how to proceed with the pH calculation. In this generic millimole table, we are only looking at the E row. Here, we see that both OH- and H+ are consumed. They have reacted stoichiometrically, and neither one is in excess. Because they both go to 0, this puts the reaction progress at region 3 of the titration curve, which is the equivalence point. The reaction is complete. Notice here that the only thing in solution is pure water. This means that our pH of the solution will be equal to the pH of water. In general, you can just remember this pH of 7, and don't have to actually do the calculation, but here's why it works. We know that in pure water, the concentration of H+ that dissociates is related to the autoionization constant of water, or Kw. At 25 degrees, Kw equals 1.0 times 10 to the negative 14, out to 2 sig figs. The mass action expression shows us that H+ times OH- equals 1.0 times 10 to the negative 14. This means that both H+ and OH- are at 1.0 times 10 to the negative 7 molar in pure water at this temperature. Taking the negative log of this value gives us a pH of 7.00. We'll start by calculating the millimoles of our hydroxide. We have 15 milliliters of solution times the molarity of the sodium hydroxide, which is 0.2500 moles of OH- over liters of solution. Liters of solution will cancel, and we'll be left with milli and moles of hydroxide. We have 4 sig figs in our volume, 4 sig figs in our molarity, and that will give us 4 sig figs for our millimoles. So doing the math, we have 15.00 times 0.2500 gives us 3.750 millimoles of OH-. Calculating our H+, we have 18.75 milliliters of solution times the molarity of the H+, which is 0.2000 moles of H+ per liter of solution. Liters of solution will cancel. And checking our sig figs, we have 4 sig figs in our volume, 4 in our molarity, and so we will have 4 sig figs in these millimoles as well. Doing the math, we have 18.75 times 0.2000 rounded to 4 sig figs gives us 3.750 millimoles of H+. Setting up our millimole table, we have OH- plus H+ going to water. We'll set up our rows, initial, change, and end, and include our units, which are millimoles. And we'll put a line through the water. So filling in the values, we have 3.750 for hydroxide, 3.750 for hydrogen ion, and we'll subtract 3.750 from each reactant. That gives hydroxide going to 0 and hydrogen ion going to 0. And when both values are at 0 in the E row, that tells us that we're at the equivalence point. And for a strong acid or a strong base titration, that gives us a pH of 7.00.